For decades, if you wanted to build a game, you had to fit your amazing vision into an engine someone else built. But what if that was totally backwards? What if you could shape an engine to fit your vision, like instantly? Let's dive into a new way of thinking that could completely change how we build interactive experiences.
And that's where this quote really hits home. This is the whole promise of a platform called Cadence. It's all about giving that creative power, that agency, back to you, the developer. It's about putting you back in the driver's seat.
But, to really get why this is such a huge deal, we first have to talk about the problem. We need to unpack this fundamental trade-off that has defined game development for, the last 20 years. See, development has really been a tale of two eras. First, there was the era of the forge. This is where you built everything from scratch. You had total control, which was cool, but you spent years just wrestling with low-level tech instead of making your actual game. And then came the era of Titans. You know who I'm talking about. The big, one-size-fits-all engines like Unreal and Unity. They're incredibly powerful for sure, but they come with their own rules, their own black boxes, and their own creative limits. And that's always been the choice, right? This classic trade-off. Do you want total control, but with insane complexity? Or do you want immense power, but with almost no real flexibility? Either way, you end up fighting your tools instead of actually creating with them.
So Cadence is proposing a third era, a new way forward that lets us move beyond this trade-off completely. It's about giving us a whole new blueprint for creation.
Okay, so what is Cadence? The first thing to get is that it's not another engine. Not at all. It's an engine factory. It's this modular, AI-native platform that literally generates a custom-fit, super minimal, and high-performance engine that is tailored exactly to what your project needs. Now, the magic behind this whole thing is a system called the Model Context Protocol, or MCP. The best way to think of it is as the language you use to describe the engine you want. It's basically infrastructure as code, but for games and real-time simulations. You just declare what you need, and the system figures out the how. And this changes everything about how you start a project. You don't start by writing low-level C++ or anything like that. No, you start with your creative intent. You fill out this simple, structured document called a design brief, and its job is to capture the high-level goals, even the feeling you're trying to create. And this is where it gets kind of mind-bending. You can literally tell the system that your experience goals are things like cozy and exploratory. Think about that. You're taking these abstract creative keywords, and the AI is using them to figure out the actual technical requirements for your engine. You're turning a vibe into functional code. Okay, so you've written the blueprint, you've described the feeling. How in the world does that become a real working prototype? Well, this is where the automated factory kicks in. The whole thing is this really slick AI-powered pipeline. It starts by taking in your design brief. Then it synthesizes all the technical needs from that brief. From there, it configures the perfect engine for you, selecting and wiring up just the right modules. It generates the starter code to get you going, and finally, it packages the whole thing up and deploys it. The key player here is an AI called the Builder Agent. It's like the factory foreman managing this entire process. And it takes your high-level intent and turns it into a compiled, runnable prototype. And get this, the whole thing happens in minutes. We're talking minutes, not the weeks or months it usually takes just to set up a new project. And this whole approach, it's way, way bigger than just making one type of game. Its modularity means you can unlock an absolutely incredible range of applications across totally different fields. Because the system is built on these declarative blueprints, you can create specialized MCPs for pretty much any domain you can think of. You could have one that designs for accessibility from the ground up, another one that fuses an educational curriculum right into the gameplay loops. Or you can get really serious and use MCPs for building things like medical-grade surgical simulators or secure military training platforms. The possibilities are just huge.
But I know what you might be thinking. What if you're already deeply invested in an existing engine? Well, this is where Cadence pulls out its most powerful feature. It doesn't force you to abandon the tools you already know and love.
Cadence has these things called integrator MCPs, which can take your custom-generated prototype and export it as a native, ready-to-use project for Unreal Engine, for Unity, or for Godot. This means it's not a replacement for those engines, it's a massive accelerator for them.
And check this out. It even works backwards. There's a reverse integrator that can take your existing, complex Unreal or Unity project, analyze it, and turn it into the standard Cadence format. This means you could bring legacy projects into this new ecosystem, or maybe even port them from one engine to another. It's pretty wild.
So when you put all of this together, it really does point to a different future for how we create things. This isn't just about building one engine, it's about creating a living, evolving system.
You see, the long-term vision for Cadence isn't for it to be some static piece of software. It's designed to be your R&D partner, a system that maintains, optimizes, and evolves itself using a whole suite of advanced AI agents. And to do that, Cadence will use what they call visionary agents. You'll have the researcher agent constantly scanning academic papers and code repos to integrate the absolute state-of-the-art techniques into your engine. But then there's the spearhead agent. Its job is to propose entirely new algorithms, to actively push the boundaries of what's even possible in real-time tech.
Ultimately, if you need a simple way to wrap your head around all this, here it is. It's Terraform for game engines. A declarative, predictable, and incredibly powerful way to automatically build the very foundation of any real-time simulation.
Which brings us right back to the most important question of all. If all those technical barriers just vanished, if your engine could build and evolve itself to perfectly match your vision, what would you create?